here's a word problem, and we're going to strike quite a few word problems that we need to be able to translate from the English text into some sort of equation and come up and do some calculus. And so there's some certain triggers. So let's just go through it and we'll pick it apart and then put it all back together again. Manufacturer wants to design an open box. Now what's an open box? Means it's got no lid. So it's got a base, 4 vertical sides, or vertical faces rather, and it's got no top on it. A surface area of 108 square centimetres. What dimensions will produce a box with the greatest volume? Greatest volume. Now that should trigger that we're going to find dV, if we make x the length of the base. So we're going to be looking for finding dV dx, so finding turning points and so on. So we've got to come up with an equation for V, for the volume of the box, and then it's going to change as we change the side of the base. So good place to start with these is a diagram, and if you're not too good with doing 3-dimensional ones, just draw a parallelogram and draw that same parallelogram straight above, and then just join up the corresponding, and that'll suffice. Doesn't have to be in 3 hidden things and that, so we'll just do it like that. So we know something about the surface area. It doesn't have a lid, so this shaded section here does not exist. So we've only got 5 faces. We need to get some, there's no mention here of x's and all that sort of stuff and variables, so we need to introduce those. So if that is x and it's a square base, that's got to be x there. So if we're introducing variables, we should define what they are. So let x centimetres be the side of the base. It's a square base. And to find volume, we need the height as well. So we'll call that h, and h centimetres be the height of the box. So we've got a rule for the volume. So the volume equals, and from those rules I've given you previously, the volume of a prism, this is a prism, is equal to the area of the base, x squared, times the perpendicular height. So there's the volume. We cannot just find the derivative with respect to x, because as you vary x, h is going to vary as well. So we've got 2 variables here, and we can only find the derivative when we've got one variable on the right. So we need to get rid of one of those and just have it in terms of one variable. Now, there is always in these questions enough information to be able to do that. And if we go back, we haven't even used the surface area. Okay, we haven't even used that yet. So we know that the surface area is equal to 108. Now what is it in terms of x's and h's? It'll be the area of the base, which is simply x squared, and then to that we've got to add the area of the 4 vertical faces, and each face would be x times h. So there'll be 4 lots of those, and that's the surface area. Now, looking at that, we can rearrange to get one of these variables, x or h, by itself. Now, looking at x, it's very, very difficult to get x by itself here. So I think h is going to be the way to go. So we take the x squared over the other side. And finally, we divide both sides by 4x. And we get, we'll do it out here, we get, they will cancel each other, and we get h equals 108 minus x squared all over 4x. So that'll give us the volume equals x squared. Now instead of that h here, we can substitute in 108 minus x squared all over 4x. that x will cancel with that. That's connected to the top by a multiplier. That x is connected to the 4 by a multiplier, so I can indeed cancel. X into x squared just goes x, and so we get x outside of 108 minus x squared all over 4. Probably we should remove brackets and we get 108x minus x cubed all over 4. Okay. Our next step is to give ourselves an idea. This is a greatest and least value, so we want to actually find out what sort of domain we've got for x. So domain for x, well, it's a little bit nonsensical, but the least value that x could take is x has got to be greater than or equal to 0. So that would be the smallest value that x could take would be 0. As I say, it's a bit nonsensical because virtually means you've got no base and all the surface area wouldn't be in the vertical faces. And the greatest value that x could take would be as if you've got no faces going up there, and all the surface area would be in the base. So in that case you would have x squared, because you've got no h, x squared would be equal to 108. That would be the surface area. So that's like you've got no height at all. And I know it sounds a bit nonsensical, but algebraically that will give us the domain for x. So you've got x squared is equal to 108, and so therefore x has got the greatest value. So this is least, and this will be the greatest. So x squared, x equals square root of 108. So therefore x has got to be less than or equal to 108, square root of 108. So that's the greatest, and this is the greatest value of, not of the volume, but of x. And that'll be the greatest x value. Least value, x equals 0. So in other words, x has got to be greater than or equal to 0 or less than or equal to the square root of 108. So that gives us our domain. So our next step is to find the derivative. So we've got to find dv dx equals, so we're going to find derivative with respect to x of this. And to do that, it's probably best to split this up into, we can take the 4 outside, so that'll be 1/4 d dx of 108x minus x cubed, and that'll be equal to 1/4 108 minus 3x squared. So that's dv dx, so at a turning point, dv dx equals 0, so that's going to be equal to 1/4 108 minus 3x squared. We're going to solve for x here, multiply both sides by 4, and we get 0 equals 108 minus 3x squared. Bring the 3x squared over to the left hand side, 3x squared equals 108. Divide right through by 3 and you get x squared equals 36. So x equals plus or minus 6. So we can reject x equals -6 because we're talking about the length of the side of a box. So just put not possible to have a -6 for centimetres for a length. So therefore x equals 6 happens when we've got a turning point. Now, we don't know whether that turning point is a maximum or minimum, but all we've got to do now is go through, and just like our absolute maximum minimum questions, we've seen from our domain for x that we've got those values. So we substitute in each of the n values and this value to see what is the greatest volume. So when x equals 0, the volume will be equal to. Now the volume is in terms of x, here it is here in terms of x. So you've got the volume is equal to 108 times 0 minus 0 all over 4, so it's equal to 0, which does not surprise us. When x is equal to 6, the volume is equal to 108 times 6 minus 6 cubed all over 4. So what's that? 648 minus 6 cubed is 216 all over 4. 432 on 4, which is equal to 108. So the volume is equal to 108. And then finally, x is equal to square root of 108. And we get volume equals 108 times square root of 108 minus 108 cubed all over 4. Now that's like square root of 108 squared. So that's like square root of 108 all raised to the power of 3. And this is minus the same thing all over 4, so that's going to be equal to 0. And that doesn't surprise us. This was the scenario and we had no height whatsoever. So it looks like we're going to have a volume here of a maximum volume in the range of 108. So we can then, the question asked not what was the volume, but what were the dimensions. So we've got maximum volume of 108 cubic centimetres. That 108 has nothing to do with this square root of 108. So maximum volume 108 when x equals 6, so the base centimetres, and then we've got to find h. Now we had a formula up there for h, and it was that h equals 108, here it is way up here, 108 minus x squared on 4x, so 108 minus x squared all over 4x. That's correct, wasn't it? 108 minus x squared on 4x, yes. So 108 minus x squared is 36 all over 24. What is that? 72 on 24, which is equal to 3 centimetres. So that's our h. So dimensions for maximum volume are 6 by 6 by 3 centimetres. So that will give us the maximum volume.